To check whenever you're inside here. But ground and power right here, there should be 24 volts DC, with it plugged in and powered up properly. So there should be 24 volts coming out of that. The 24 volts goes into the board down here, and then it converts it to several different points in there, but there's test points on there. Each one of these have labeled in here. You should be able to test for 3.3 volts, 5 volts, there should be a ground on there, 10 volts, 12 volts, and then again 24 volts. If any one of those is inactive, you've got if you don't have 24 volts coming out of the power supply and going into the board, you got a problem with the power supply. If you don't have enough voltage at each one of these test points, there's other checks that we may have to have you do. Jose's got a list of them. You'd be talking with Jose online or on the phone to discuss what you may or may not do. But again, most of the time, if you don't have a tolerance of voltage, it's going to be something to do with the power supply, not supplying enough voltage. There is tolerances I put down next to each one of these, so that should be helpful in determining the troubleshooting technique you're going to use. For instance, 5 volts, it has to be between 4.9 and 5.2, and it is a tolerance. If it's out of that spec, it's no good. Again, it has to be within the tolerance that I put down on here. Otherwise, because I've seen small variances. You can vary, like with the 12 volts and the 24 volts, up to a voltage degree. It has a tolerance of up to 1 volt. But anything less than that, usually there's going to be its percentage. With getting out of 10 volts, it's plus or minus 0.5. Anything below that is plus or minus 0.1. So it's very important that you know exactly what the tolerances are when you're making the checks. And they're all test points. Again, you can just take this right over here and take a look at it. And you'll see right here, it matches up right in this area right here. See the pictures that are right here, and each one of them that are labeled. But if you come up here and look on the board itself, I don't have my pin with me, but I'll point to it. There's a 24 volt test point right here, 12 volt right here, 5 volt, 3.3, and the one in the middle right there is a ground. So it tells you right there. You can just simply stick your negative to the ground and your positive to the test point, testing for that particular voltage. This is the bridge board. Basically, like I said before, if you have a problem with one position, then you're looking at electronic problem or mechanical inside here. It'll be the board behind here. If you have something that's affecting universally all of them, you got a power supply or a bridge board problem. This is where everything comes out. All your power for each one of these goes to the heater jacket. So any kind of heater all across the board, every one of them not working, you're going to come back here to this board back here and start making some checks. But it's easy to troubleshoot that way, knowing if you have a problem with just one position and or if you have a problem with the entire system. So anything with the entire system, universal, you need to start looking back here. It may not be wrong with back here.
In case of a power failure, just start over all? Or
What do you mean power? I mean, if you lose power on the
lose
unit
power
itself?
and comes again.
Yeah, I mean, it depends. You're talking about the lab itself losing power, coming back on again?
Exactly.
Yeah, it can cause some problems with the boards. We've had issues with not just this unit, with all of our units. But anytime you have any kind of electronics, computers are affected also. Anytime you lose power,
No, but if it is only power off, it is okay. The problem when power off, on and off.
when it fluctuates.
Yeah.
Yes,
when
because
it-
then you start getting less voltage. Any electronic system in the world, I mean, I'm an electrician by nature,
Exactly. Or
it's just looking for power to be able to come on and come off. It doesn't know any better. It's a piece of equipment. It operates on X amount of voltage. If it's the limitation, particularly I guess when I think our power supply on this, I think we have listed 100 to 130. I think on in the States. I think overseas it's
220 to 250 thing.
I think it's 2250. Is in that range?
50
Okay.
hertz.
But again, it's wider than that. We just have that stated specification for that. Like for here, I know it's 100 to 150, 100 to 130 for our 120 volt United States voltage. So again, like I said, 100 to 130. That's a wide range, but it'll actually work probably down to about 90. But we're not looking for that to be an ideal situation. Anytime you start lowering the voltage on something, it don't know any better. It starts increasing the amps. Electronics always increases the amperage on something because it's trying to draw more. It wants the power. It's power starved. And when it starts doing that, when you start increasing the amperage that's running through a circuit, you start overloading the circuit, you start burning out components is what ends up happening. So you end up burning resistors, you end up burning capacitors out. That's what ends up happening with the boards. And that's what you'll see whenever you have a power problem. And that's what you said exactly. It's not the power going off and coming back on. That usually doesn't happen. If the power struggles to go off and then struggles to come back on, meaning it's going through cycles of power trying to come back up, that's when you'll start to see problems with the unit.
And if it smells some like funny and your eyes begin to water,
Yeah.
then it's condenser.
You know, I call it installer's cologne. You start to smell that ozone from something burning, you know something went wrong.
Yeah, we know.
Warm gray smoke.
Yeah, there you go. So, but again, like I said, that's generally the kind of problems you're gonna see. And especially, you know, again, some of the labs that we go to don't have the best power in the world going to them also. And or storms. I mean, you guys are down in Puerto Rico, you guys are susceptible to a lot of the hurricane season, so.
They can do this because they have all backups. Well, when powers go off and goes on again, you lose all the job you have done. But there's no memory to keep these parameters.
No.
Graphic card.
So you just need to start over.
It looks like computer.
That's right.
It's a heat shrink on top of it, on top of a chip.
Yep. Take the heat out.
Yeah. So, but again, like I said, I tried to be, with the newer, again, and I keep saying it to everybody, the newer equipment, I have very good stuff in the documents for that. The older equipment, we're trying to get as much in there, but it's harder because we don't have as much accessibility. We're manufacturing these all the time back there, as you saw. We're not manufacturing these all the time, or the 2100, or the 5100, or some of our older legacy equipment, so it's harder to get pictures. So when one gets in here, I try to get on it and get some pictures of it, so I can come up with some more material. So I've got a lot more material in here for the newer equipment, not as much for the older, but we're working on it. So again, like I said, it's just, it basically, you know, all the PowerPoints are in there. So first and foremost is the power supply, like I said. So you either have 24 volts coming out of it or you don't. And if you don't have 24 volts coming out of it, it's the power supply. If you have 24 coming out of it going into it, you can check the 24 here on the test point. Then you can start checking the other voltage readings. If you start having a problem with the other voltage readings, you probably have a bad board.
So that one is without any fuses, I guess.
What, this is without any fuses?
Yeah.
Well, this actually is
It's fused inside.
Yes.
And
and,
that voltage has no fuses.
no, not on that one.
It should be in power supply itself. not
Yeah,
the one.
this has a ground interrupt. So it can actually, you can have it on, and it'll actually, you can trip internally. You have to turn it off and back on again to reset it. It has a ground interrupt built into it. But no, it's not fused, not on this one. The individual boards in here are fused.
Where is the
These ones
fuse
back here do
inside
that.
the switch?
Huh?
The fuse is
It's
inside.
a ground fault. It's not a fuse.
Oh, it's ground fault?
It's a ground fault. It'll trip, and then you can reset it by turning it off and back on again. So if you get a dead short inside or something that's burning up or whatever else, it'll just trip this off. Normally when you turn it on, you see the light, it starts to illuminate and it comes on. It won't illuminate, it'll kick off the power.
And with a picture as well of advanced.
This one is a spare one, or what's this one?
No, it's right now, it's a spare. With the thought of actually adding more stuff down the line.
Okay.
They always buy whatever I'll assume that when engineering went and bought these from whatever company they bought them from, maybe there was a thought to do two of them, and or maybe this was the cheapest component, the cheapest one they could get had two of them and they're only using one of them. Because again, much like NASA, when we fly the space shuttle up into space, we always go to the lowest bidder on equipment, so we do the same thing here.
Yeah, we know how shuttles were flying the last time.
The same, I mean, that's it, we're all susceptible to the lowest common denominator, which is money. People try to sell it cheap to get by with the least amount spent. So that's pretty much the electronics on it. And again, like I said, I can't stress enough about the electronics as far as troubleshooting. If you have a problem, it's just isolated to one instrument. 99% of the time, one position, 99% of the time, it's going to be in here someplace. Either it's going to be the board that's inside here, or it's going to be a mechanical issue inside. But we're talking like if you're talking about a heating problem, anything of that nature, errors that are coming up on the screen, that's going to be inside this system here. If it's happening on all of them, you need to start coming back here and looking at the power supply and or the bridge board.
And this the lower board is for.
It's for control. It's where it keeps the memory for the temperatures, temperature calibration data that's stored. That's where it does all the processing.
It's like the main board.
Yeah. It's just separated. This is the power supply, this is the power board that actually routes the power on and off back out to the heaters. So this is actually going out to each one of the heaters, and it's separated. It's a power supply board, but it's not this is the power supply and this is the power supply board, bridge board as they call it. And then this one right here is the control board. Has all the control circuitry on it. And this actually has the...
Heater board is inside somewhere, right?
Pardon?
Heater board, jacket heater board, where is it?
That's this.
This is jacket heater board.
This is what's controlling the heat, all the jackets, right here.
Wow, okay.
It's a high voltage because it's up here and here is low voltage. You see the difference between height.
The heaters works on 110 volts,
Here,
Yeah.
220 overseas.
220, and but ours,
We have different heater jackets for overseas
Yeah,
applications,
yeah,
yeah.
yeah.
We got 110 here and 220 overseas.
So what's in Canada like 120 also.
Yeah, it depends on what voltage they have. Some places,
120.
most places in
from
Canada.
120 to 130, so it varies.
Again, these, I think, as I said before, I think they run from 100 to 130 volts. These are whole. Hey, I put those things over there. If anybody wants those, you want one, you can have one.
In Peru?
Yeah,
In Peru, 220.
220, yes.
Yes.
No, pardon, 60.
60, it's not like here.
I mean, it's just a piece of tubing with the cap on it, but
helpful.
it'll definitely come in
must
handy.
search for correct plug, but you'll never get it.
It
on
can
the
go
side.
up to 240. So the range is from 100 to 240.
Well, yeah, but we
That's
use the
the
same,
range of the.
but we use the same power supply on overseas. We just have to set it over.
So the cable is different.
You probably would be able to, I don't know if we could walk you through online or on the phone, how to convert one from 110 to, like, let's say you guys somebody here in the States bought one for, what's down in Puerto Rico, Teva's down there? Activist,
I think in,
GSK's down there?
the GSK.
Okay, say GSK has units here and they decide to ship them down to, there might be 110 units here, you might have to convert them once they get down there, but converting them is probably not that hard of a process because the power supply is already, it's the same power supply.
Yeah, well, we need to change the
normally we don't
Distek
have-
cable sometimes because we leave the same in the States,
Yeah.
120 and 240. So we can convert.
You don't have places here with 220.
Here in the United States? No. Well, yes and no, it depends. It's,
Two phases, but two
well,
phases,
it depends on
We
what
have
type
two
of
phases,
equipment.
220,
It
yeah.
depends on what kind of equipment you're using.
Yeah.
Like, for instance,
Because
like,
this is something we
'cause-
have even at homes.
because
We have
in
two
my
plugs,
home,
one 110 and the other one is 220.
my
Yeah.
house right now, I got one,
Yeah,
I got
yeah,
110
yeah.
in my house, or 115, 110.
Yeah, for rest,
But
the
in the
natural,
basement, I
it's
have
always one
220 to
phase.
run the washer and the dryer.
Yeah.
The washer
So,
and
but you
dryer.
run two phases, one
So how do you get
10
that?
and then you get
Two
220.
phases together. or what?
Yeah, you get phase to ground, to neutral, and that's it. But then it won't be a good grounding, and that is most of our problem there with electronics because of that.
Yes.
Because most of the cities there, the generators are 110, then with 220 volts instruments, we don't have good grounding.
And then you got fluctuating.
So then you don't have like not ground but zero option. So
No.
you have a phase.
Neutral, we call it neutral.
Neutral
Yeah,
and,
we don't have
and
yeah.
protection.
Mhm.
Yeah.
Yeah,
So to have two phases.
yeah, two phases.
And that's not good.
Yeah, sure, it is that.
It's dirty power.
Yeah.
Yeah.
But now they start to standardize everything. Maybe they will change the generators.
We were remodeling our kitchen back home, and
Yeah,
okay,
because-
I did because it's old
Yeah.
building. So one part was complete new electricity. The old one was still with the cables, which are isolated with I don't know with cotton or something.
Mhm.
The old version from 1930s.
Wow.
So I put one cable, second cable, and 25 watts lamp was burning like 100. Oh, this is
Oh, wow.
something is not okay. So I noticed that there are two phases, so it was actually 400 volts.
Ooh. That's a lot of volts.
And my father, it was electricity. It was good for so long. It could be also for the next 50 years, yeah, until it will melt somewhere.
All right, we can put that cover